start. Okay. So let's start. Acha, so in the last class we were discussing fundamental principle of multiplication, right? Fundamental principle of multiplication. Do you remember
Good
the
afternoon, sir.
Good afternoon. Good afternoon. Do you remember when fundamental principle of multiplication is applied? In which situation we apply fundamental principle of multiplication to find out what we apply fundamental principle of multiplication, right? Okay. For example, let me just remind you. For example, uh, suppose there is a place A here, there is a place B here, there is a place C here. Okay, and suppose to go from A to B there are three routes. Okay, to go from A to B there are three routes, R1, R2, R3. Now suppose to go from B to C we have two routes. Okay, R4,
Yes, sir.
R5. Now the thing is, if I want to go from A to C via B, if I want to go from A to C via B, how many routes can I take, or how many ways are there to go from A to C via B? How many ways are there to do this, to go from A to C via B? Okay, how many different ways are there? Six different ways, right?
Sir,
There's
six
six
different
different
ways.
ways. Okay, what are they? Now suppose from A to B I go via route 1, and from B to C I go via route 4, and suppose from A to B I go via route 1, but from B to C I go via route 5. Similarly, suppose from A to B I go via route 2, and from B to C I go via route 4. A to B I go via route 2, and B to C I go via route 5. A to B I go via route 3, B to C I go via route 4. A to B I go via route 3, B to C I go via route 5. So as you can see here that clearly, in order to go from A to C via B or through B, we can do this in six different ways, right? We can do this in six different ways, right? These are the six different ways. But okay, this was a simple problem. This was a simple problem, that's why it was easier for us to calculate it. Okay, by doing like this. But it was if it was a complicated problem, if it was a complicated problem, suppose I add another place. Suppose there is another place D. Suppose here. Suppose I add another place. Let's see. Suppose there is a place A here, there is a place B here, there is a place C here, and let's say there is another place D here. And let's say in order to go from A to B we have three routes. In order to go from B to C we have four routes. In order to go from C to D we have five routes, suppose. In this case, if I ask you to find out the number of different ways in which we can go from A to D via B and C, that means not directly from A to D, you have to go from A to B, then from B to C, then finally from C to D. If I ask you how many different ways can you do it, okay, if you do it in this way, it will take a lot of time here. If you write it that this is road 1, road 2, road 3, road 4, road 5, road 6, road 7, road 8, road 9, road 10, road 11, road 12. If you do it like this, and if you count it like this, if I go from A to B via road 1, then from B to C via road 4, then from C to D via road 8, then if I go from, it will take a lot of time, right? Right? So in order to avoid, hello, get it? Hello, get it?
Yes, sir.
Okay. So
Yes, sir.
okay. So
Yes, sir.
okay. So basically what we are doing here, we are doing what? Counting. We are counting the number of different ways in which we can complete a task. The number of different ways in which we can complete a task. For example, in this case, our task was to go from A to C via B. And our question was, in how many different ways can you do it? So we were counting that. In this question also, our task is to go from A to D via B and C. And the question is, in how many different ways can you do it? So in order to solve these kind of problems easily, we'll take the help of a concept called fundamental principle of counting, right? We have already covered this. So I'm just trying to remind you. FPM, FPM, short for what? Fundamental principle of multiplication. Fundamental principle of multiplication, because here we are going to do a bit of multiplication. Okay, in fundamental principle of multiplication, what happens actually? Let's see. Suppose I give you a task. Suppose I give you a task. This is a task. Okay, suppose I give you a task, and suppose this task is being carried out in suppose, let's say, two stages. Let's say two stages. Let's call them event 1 and event 2. Just like here, our task was to go from A to C via B, and we did this in two stages or two events. Stage 1 or event 1 was what? To go from A to B. Event 2 was what? To go from B to C, right? Right? Okay. So suppose there is a task which takes place by event 1 and event 2 happening one after another. Okay, first event 1 happens, following which event 2 happens, and then the entire task is complete. You get it? Hello, get it or not?
Yes, sir.
Okay.
Yes, sir.
Okay. Now keep in mind, here both events have to happen. Both events have to happen. In order for this task to be completed, here both events have to happen. Just like here, in order to go from A to C via B, both events have to happen. Event 1, you have to go from A to B, then event 2, you have to go from B to C. So if both events have to happen one after another for the entire task to be completed, and let's say event 1 can happen in m different ways. Let's say event 1 can happen in m different ways. Then after event 1 has happened, after event 1 has occurred, let's say event 2 happens in n different ways. Let me rephrase. Suppose event 1 can happen in m different ways, and after event 1 has already occurred, now that event 2 is about to happen, event 2 can happen now in n different ways. In this case, the entire task can be completed in m into n different ways. Okay, this is called what? Fundamental principle of multiplication. Got it? Got it or not?
Yes, sir.
Yes, sir.
Got it.
Okay.
Yes, sir.
Okay. So in this example, you see that. Good afternoon. Here two events are happening to go from A to B, which can happen in how many ways? Here event 1 is to go from A to B. This is event 1, first event. And we know that it can happen in three different ways, right? You can go from A to B in three different ways. Three different ways. Now, once event 1 has already happened, that means you have already you have already reached the place B. Now you are at place B. Now you want to go from B to C. Event 1 has already happened. Now event 2 is about to happen, which is to go from B to C. Who is this? Okay. So event 1 has already happened. That means event 1 has already happened means what? You have already taken one of these three routes, right? There are three routes to go from A to B, three different ways to go from A to B, and now that event 1 has already happened means what? You have taken one of them, right? You have taken one of those two routes, one of those three routes, and you have now reached place B. Now you want to go from B to C. In how many different ways can you do that?
Sir, two different ways.
Two different ways. Therefore, the entire task, which is to go from A to C via B, it can happen in 3 times 2 is equal to 6 different ways. You get it? 6 different ways. This is what fundamental principle of multiplication is all about, right? Now keep in mind here that this fundamental principle of multiplication is not restricted to only 2 events. No, it's not restricted to only 2 events. It can be extended to any number of events. For example, here in this example, we are trying to go from A to D via B and C. This is our task. Now, in order for that task to be complete, 3 events have to happen one after another. First event, you have to go from A to B. Second event you have to go from B to C. Then third event you have to go from C to D. After these three events happen one after another, then only the entire task is complete. Now I want to know in how many different ways this task can be completed. That is, in how many different ways I can go from A to D via B and C. Well, how do I do it? First of all, event 1, which is to go from A to B, it can happen in how many different ways?
So 3 different ways.
So three different ways.
Now imagine event 1 has already happened. That means you have taken one
So
of
then
these.
we have to four different ways to B to C.
Oh, yes. Now that event 1 has already happened, that means you have already taken one of these three routes and you have now reached place B. Now you want to go from B to C, which is event 2, and it can happen in 4 different ways. Event 3, okay, now event 2 has also already happened. That means you have taken one of these 4 routes and now you are at place C. Now event 3 is going to happen. You want to go from C to D. Well, in how many different ways can you do that?
So 5 different
5
ways.
different ways.
So 5 different ways.
So here 3 events are happening one after another. The first event happens in 3 different ways, following which the second event can happen in 4 different ways, following which the third event can happen in 5 different ways. Therefore, the entire task can happen in 3 into 4 into 5 is equal to 60 different ways. That means there are 60 different ways in which you can go from A to D via B and C. Get my point so far? Clear?
Yes, sir.
Okay. This was
Yes,
what
sir.
this was what we discussed in the last class. Okay. So and also what else we discussed? We discussed fundamental principle of addition. Fundamental principle of addition. Fundamental principle of addition, I give you an example. Suppose, first of all, let's say I have a place here A, I have a place here B, I have a place here C. Suppose I have a place here C. Now, in order to go from A to B, I have 3 routes. In order to go from A to C, I have 2 routes. Now, let's understand the task here. The task here is to leave place A. We have to leave place A. Well, here, in order to leave place A, you will either go to place B or place C, right? In order to, because there are 3 places here in this drawing. So if you want to leave place A, here either you will go to place B or you will go to place C, right? So that means this task.
Yes, sir. So
That
we have
mean-
5 different ways.
Yes, that means for
Yes,
this
sir.
that means for this task to be completed, here either of these two events will happen, not both. Either event 1 you will go from A to B, or event 2 you will go from A to C. Either or. Unlike the previous case, in the previous cases, in these examples of fundamental principle of multiplication, compulsorily all the events had to happen one after another. But here, the task to be completed, one of these two events is to happen, not both. So in this case, if I want to calculate how many different ways I can complete this task, then how many different ways? That 3 plus 2 is equal to 5 different ways. This is called fundamental principle of addition. So what does fundamental principle of addition say? That suppose there is a task here, and suppose this task can happen by event 1 or it can happen by event 2. See, not both. One of them has to happen, not both. And let's say event 1 can happen in m different ways, and let's say event 2 can happen in n different ways. In this case, for the task to be completed, it can be done in m plus n different ways. You get my point so far? This is called fundamental principle of addition, right? Get it?
Yes,
Okay.
sir.
Yes, sir.
We also went through two practical examples in the last class, right? We also went through practical examples. So let's just talk about those two practical examples. First of all, so let's take the same question. I will give a twist in the same question and form the second question. In the first question, we will apply fundamental principle of multiplication, and in the second question, we will apply fundamental principle of addition. Now the question is, there are 3 boys and 2 girls in a class. If a boy monitor and a girl monitor, keep in mind here I am using the word and a girl monitor, girl monitor is to be chosen, how many different ways can it be done? How many different ways can it be done? Okay. So before we solve this question, remember here in this question the keyword is and I will tell you why the keyword is and. First of all, let's try to understand the question, try to understand the situation. The situation is, there are 3 boys and 2 girls in a class. Let's say there are 3 boys. The boys are, let's say, B1, B2, B3, and there are 2 girls in the class. Let them be G1 and G2. Now what is the task here? The task is, we have to choose a boy monitor and a girl monitor. That means here you have to choose a boy monitor and also a girl monitor, compulsory, right? You have to choose 2 people, one a boy monitor and a girl. And the question is, in how many different ways can this task be done, or in how many different ways can you choose a boy monitor and a girl monitor? So you see here, for this task to be completed, 2 events have to happen one after another. First event, you choose a boy monitor. First event, you choose a boy monitor. Now once you have chosen a boy monitor, then we will go on to choose a girl monitor, and your task is complete, right?
So 6 different ways.
Yes. That means here your task is being carried out in 2 stages, or 2 events, and here both events have to happen one after another, because here you have to choose boy monitor as well as a girl monitor. So after boy monitor is chosen, you have to also choose a girl monitor, then only the entire task is completed. Now you see the first event can happen in 3 different ways, right?
Yes, sir.
Because there are 3 boys. Okay. Now once you have chosen a boy monitor, now you want to choose a girl monitor. Well, there are 2 girls, so you can choose a girl monitor in 2 different ways. Then the entire task, which is to choose a boy monitor and a girl monitor, can happen in 3 into 2 is equal to 6 different ways, right? In 6 different
Yes,
ways
sir.
you can choose a boy monitor
Yes,
and a
sir.
girl monitor. Where both events have to happen, both have to happen, and both have to happen. Okay, and if you want illustration, then it's very easy. Suppose you chose B1 as boy monitor and G1 as girl monitor, or suppose you chose B1 as boy monitor and G2 as girl monitor. Similarly, suppose you chose B2 as boy monitor, G1 as girl monitor, B2 as boy monitor, G2 as girl monitor, B3 as boy monitor, G1 as girl monitor, B3 as boy monitor, G2 as girl monitor. You can see that you can do it in 6 different ways. Now the thing is, sometimes this question arises in your mind. The question is, sir, what will happen if I choose a girl monitor first and then boy monitor? Because sir, in this example, because in the question nowhere it is saying that you have to choose a boy monitor first then and then a girl monitor. No, It is just asking us to choose a boy monitor and a girl monitor. Now it's up to me whether I choose a boy monitor first or a girl monitor first. It's up to me. So it doesn't make any difference here. It doesn't make any difference here whether you choose a boy monitor first, then a girl monitor, or whether you choose a girl monitor first, then a boy monitor. It's the same thing. No difference, right? After all, we want a boy monitor and a girl monitor. That's it, right? So here you can do it in the other way around also, and you will get the same answer, right? For example, you will say that I will choose the girl monitor first, following which or after that I will choose the boy monitor. Then girl monitor being chosen can be done in 2 different ways. Boy monitor can be chosen in 3 different ways, and the entire task is being carried out in 2 into 3 is equal to 6 different ways. You will get the same answer. So you see here, the order in which the events are happening, the order in which the 2 events are happening, that doesn't matter here, right? That doesn't matter here. Clear?
Yes, sir.
But in some examples, order matters. In this particular question, order didn't matter, but in some questions, order matters, and we'll talk about those questions also. Okay. Now let's just bring a little twist to this question. The question is the same number of boys, same number of girls, 3 boys, 2 girls, but now the question is, in how many different ways can you choose a boy monitor or a girl monitor? Look, I replaced the word and by or, and the question changes. Choose a boy monitor or a
5
girl.
different ways.
Yes. If you try to understand this question, here we do not have to choose a boy monitor and a girl monitor. Here we will have to choose only one. Either we choose a boy monitor or we choose a girl monitor. Unlike the previous case where you had to choose a boy monitor as well as a girl monitor. But here you have to choose only one. So that means here also 2 events are there. One is choosing a boy monitor, which can happen in 3 different ways. Then the second event is choosing a girl monitor, which can happen in 2 different
The 2 different ways.
But here both events do not have to happen. Either event 1 or event 2 will happen. So the entire task can be completed in 3 plus 2 is equal to 5 different ways. So keep in mind, when the question involves either or, you will do what? Fundamental principle of addition.
Addition.
When the question involves and, you will do what? Fundamental principle of multiplication.
So multiplication.
Okay. I hope everybody got it right. Or if you
Yes,
have
sir.
any doubts, you can ask now. Now you can ask. If you have any doubts so far, whatever we learned, if you have any doubts so far, you can freely ask now. Anybody?
No, sir.
No, sir.
No, sir.
Okay. So let's move on. Yes. So what I just told you that in the example that we just took, in this example, order of the events didn't matter. I mean, in which order we are doing the events. If you are doing event 1 first, then event 2, or event 2 first, it didn't matter. But I will give you examples where order matters. We'll see. So let's just do some more questions from your book itself. Okay, so let's start with a very easy question. Very easy question. The question is, how many 3-digit numbers can be formed using the digits 1, 2, 3 if bit 1 repetition is allowed, bit 2 repetition is not allowed. Don't worry about it, not very difficult, I will explain. So let's try to understand that here we have to form a 3-digit number. It is our task. We have to form a 3-digit number. It is our task. And how shall we form a 3-digit number? We shall form a 3-digit number.
A 3-digit number will
Using-
contain a ones place, tens place, and 100 place.
We shall form a 3-digit number using 1, 2, 3, not anything else. Okay, using only 1, 2, 3. Okay, that means your 3-digit number can be 1, 2, 3, 123, 321, like this. Okay, your 3-digit number must not involve any other digit. Okay, only using 1, 2, 3. Now there are two conditions laid out. In the first condition, it says repetition is allowed. Well, what does it mean? Repetition is allowed. Okay, let's just talk about it. We have been given 3 digits 1, 2, 3, and we want to form 3-digit number. And suppose I say that repetition is allowed. Repetition is allowed means what? I can form this kind of number. It's okay. I can form this number. It's okay. I can form this number. It's okay. You see, all these 3 numbers, they have been formed using these digits, and here repetition is allowed. I can repeat a digit as many times as I want, right? Clear? Repetition is allowed. But in the second bit, it says repetition is not allowed. Repetition is not allowed means I cannot repeat any digit in the second bit. That is, in the second bit, this kind of number will not be accepted, because even though you are using these digits, but you are repeating some digits, and repetition is not allowed in the second bit. So I hope you understood the two conditions. Repetition allowed means what? Repetition not allowed means what? So let's just do first question. First bit, repetition is allowed. Okay, so I am writing it RA. RA means repetition is allowed. Now you see, you want to do what? You want to form a 3-digit number. This is your task, to form a 3-digit number. This is your task, to form a 3-digit number. And the question is, how many 3-digit numbers can be formed? Or I can say, how many different ways can you do this task, right? Because the task is to form a 3-digit number. It is asking you how many 3-digit numbers can you form. So I can say, in how many different ways can you do this task, which is to form a 3-digit number using these digits, and repetition is allowed. Okay, so now you see the task of forming a 3-digit number, it is carried out in 3 stages. Stage 1, you have to fill the ones place, well, not in the same order usually. Then you have to fill the tens place. Then you have to fill the hundreds place. So once you have filled all 3 places, your 3-digit number is formed, right? Complete. Now we want to know how many different ways can you do it. Repetition is allowed. When repetition is allowed. Okay, let's see. Now here you see, you can fill any of the 3 places first. You can fill any of the 3 places first. It doesn't matter which one you want to fill first. But I will give you some examples where there will be some restrictions, that you can't fill this first, you have to fill that first. I will give you examples. But here in this case, to do the task, it will happen in 3 different stages or 3 different events. Event 1 to fill the ones place, event 2 to fill the tens place, and event 3 to fill the 100 place. Also you can write it, you can also think about like this. Event 1 is to fill the 100 place, then event 2 is to fill the tens place, then event 3 is to fill the ones place. Usually we have a habit of going from 1 to 10 then to 100. Okay, otherwise here there is no problem. So now you see that here all the 3 events have to happen one after another, right? All of them have to happen one after another, right? It is not an either or case. All of them have to happen. The first event, which is to fill the ones place, it can be done in how many different ways?
So 3 different ways.
3 different ways. Because here you can place 1, or you can place 2, or you can place 3. In 3 different ways you can fill this place. Okay. So now suppose you have filled this place with some digit, let's say 3. Suppose you have filled with this place some digit, let's say 3. Okay. So now you are going to fill the tens place. Now you are going to fill the tens place. Will you see, here repetition is allowed, right? Repetition is allowed. So now you tell me in how many ways can you fill the tens place?
So 3 different ways.
3 different.
3 different ways.
Because repetition is allowed. no matter which of these 3 digits you have placed here, again, no matter which of these 3 digits you have placed here, while you are trying to put a number here, there is no problem. I mean, repetition is allowed. Whatever number you have filled here doesn't matter. I can fill any of these 3 numbers here, 3 digits here. I don't care, because repetition is allowed. No problem. So it can be done in 3 different ways. Now I want to go to fill the 100 place. Well, how many ways can it be done?
The 3 different ways.
3 different ways. Because repetition is allowed. I don't care which of these 3 digits you have placed here. I don't care which of the 3 digits you have placed here. I don't care. While I am trying to fill a place, repetition is allowed, so I can fill any of the 3 digits in any place, and I have myself a 3-digit number. Now, how many such numbers can be formed, or how many different ways can you do this task? See, event 1 happens in, yes, event 1 happens,
27.
yes. So all 3 events have to happen one after another. First event happens in 3 ways, following second in 3 ways, third in 3 ways. So according to fundamental principle of multiplication, the entire task of forming 3-digit number can be done in 27 different ways, and that means you can find 27 different numbers, right? 3-digit number. Now let's move on to the second part of the question, where it says repetition is not allowed. Okay, so here also we want to do the same. We want to form a 3-digit number. But here repetition is not allowed. That means you cannot use the same digit more than once. You cannot use the same digit more than once. If you have placed, suppose you have placed 1 in the ones place, then you cannot place the same 1 in the tens place or in the 100 place. Suppose you have placed 2 in the 100 place, you cannot put the same 2 here or here. Repetition is not allowed. Also, this task will be completed in 3 stages or 3 different events. First event is to fill the ones place, then to fill the tens place, then to fill the hundreds place. Well, first event to fill the ones place, it can happen in how many different ways now? Tell me.
The 3
3
different
different
ways.
ways.
3 different ways, right? Okay, fundamental principle of multiplication says what? After one event happens, then another event happens. Means events have to happen one after another. So now event 1 has already happened. Event 1 has already happened means you have put one of these 3 digits already here. So whichever you want. Suppose you have pushed, suppose you have put 2 here. Now you want to fill the tens place. Well,
So 2 different ways.
The 2 different ways.
2 different ways. So now event 2 has already happened. Event 1 happened, then event 2 already also has happened. That means here in this place you have put either 1 or 3, one of them, right? Suppose you have put 3 here. Now when you go to fill this place, look, you cannot put 2 and 3 here. You cannot put 2 or 3 here because they have already been used. Repetition not allowed. So here you can do it in how many ways?
The
1
one
different
way.
way.
1. So the entire event can happen in how many different ways? 3 into 2 into
Oh,
1
6
is equal
different
to
ways.
6 different ways.
So 6 different ways.
So in 6 different ways we can do this task. Everybody got it?
Yes, sir.
What about the others? Hello?
Yes, sir.
Yes, sir.
Yes.
Oh, oh. So this question is done. And let's do a different type of question. Now the question is, how many 3-digit numbers can be formed? Well, let me just bring a twist to the question. How many 3-digit even numbers can be formed using the digits 1, 2, 3 if repetition is not allowed? If repetition of digits is not allowed. Digits is not allowed. See, the question is not at all difficult because I will show you how the question is very easy. Well, you see that here also we have been given 3 digits to use, 1 2 3, right? We can't use any other digits. We will use only these digits. Just give me a minute. Okay. Okay, so here also we have been given 3 digits, 1 2 3. We can't use any other digit, right? And our task here is what? What is our task here? Can anybody tell me?
Say, to make an even number.
3-digit even number, right? Yes. Here our task is to make a 3-digit even number. Not just any number, but even number. We have to form a 3-digit even number. And also repetition of digits is not allowed. You cannot use the same digit more than once. Okay, so let's see which kind of numbers are allowed here, which kind of numbers are not allowed. Suppose this number, no, it's not allowed because it's not an even number, right? It's not an even number. This number, yes, allowed. So how
Yes,
many?
sir.
Yes.
Yes.
How? Yes. Now the question is how many such numbers, how many such 3-digit even numbers we can form if repetition is not allowed. Okay, let's just try to understand. So here also the same thing. 3 different events will happen. Event 1 to fill the ones place. You have to fill the ones place. You have to fill the tens place. You have to fill the hundreds place. Well, let me just tell you one thing. In this example particular, here you could have started with the 100 place, then the tens place, then the ones place, no problems. You would get the same answer, 27. Because here also the order of the events do not matter. Whichever place you want to fill first, it doesn't matter. Just like whether you choose boy monitor first or girl monitor first, didn't matter. Here also if you filled 100 place first, then tens place, then ones place, you will do what? 3 into 2 into 1. You will same get the 6 as an answer. But in this question, there is a restriction in the ones place. There is a restriction in the ones place. What is that restriction? I want to form an even number, 3-digit even number. That means in the ones place, I cannot fill 1 or 3. I can only put 2 in the ones place, right? Because there is a restriction, even number you have to form, right?
Yes, sir.
So you see here in this question, there is a restriction in filling the ones place. Therefore, you have to compulsorily fill the ones place first. This event will be done first. Unlike in the previous examples where you could have filled the 100 place first, then tens place, then ones place. But here compulsorily you have to fill the ones place first because there is restriction. Okay. Now in how many different ways can we fill the ones place? Only one way.
For one difference.
Only one. Because I want to form a 3-digit even number, so I can put only 2 here, not any other digit. I have only one way to do it. So I have put 2 here, right? I have already put here 2, and it says repetition is not allowed. Not allowed means I cannot use the same digit more than once. Now when I am going to fill the tens place, after I have already filled the ones place, that means 2 has already been put here. Now I want to go to fill the tens place. In how many different ways can we do it? 2 different ways, isn't it?
For two different ways.
ways.
1 or 3. Well, now tens place has already happened. Already filled. It has been already filled. You have already completed the second event also. So one of these 1 or 3, one of these two digits you have already placed here, whichever you want. Suppose you have put 3 here. Repetition is not allowed. That means you cannot put 2 or 3 in the 100 place now. In the 100 place, you can put, in the 100 place can only be filled in only one way, right? Because you have only
For
one digit left. You have only one digit left. So one way. That means the entire task can be completed in how many different ways? 1 into 2 into 1 is equal to
The
Two different-
two
ways.
different. And do you want, that means such 3-digit even numbers can be formed, 2 such 3-digit even numbers can be formed, right? And do you know
Yes,
what
sir.
those numbers are? One is 312, 132.
Sir, 132.
Only these two 3-digit even numbers you can form without repetition of digits using 1, 2, 3. Only these two. You get it? Clear?
Yes,
Okay.
sir.
Yes, sir.
Okay. Now let's talk about a very interesting question. The question is, how many 3-digit numbers are there? Well, this question, any I mean class 2, I think class 3 or class 4 student can answer this question, right? Standard 3, standard 4 student can answer this question. How many 3-digit numbers are there? Well, 3-digit numbers start with 100, then end with what? Yes,
Sir, 999.
999.
So if I ask you how many 3-digit numbers are there, it is very easy to do. 999 minus 100, whatever number comes, sorry, minus 100, whatever number comes out, then add 1 to it. Just like how many numbers are there from 1 to 10? How to do it? 10 minus 1, then plus 1. 10, right? Hello, get it?
Yes, sir.
10. This is the way. So any class, any standard 3, standard 4 student can answer this question. Then why am I asking you this question in 11th standard? Because now we are going to answer this question in a different way using fundamental principle of multiplication. Okay, so we want to form a 3-digit number. That means the same thing. We have to fill 3 places: ones place, tens place, hundreds place. And here there are no restrictions. I mean here it is not asking us to use only 1, 2, 3 or 3, 2, 5. nothing.
Repetition is allowed in this case.
Yes, here it is asking us how many different ways can you form a 3-digit number. It is not asking us that you should form a 3-digit number using only 4, 5, 6 or using only 7, 8, 9. Not like this. You can use any digit: 0, 1, 2, 3, 4, 5, 6, 8, 9. Any of the digits you can use here. Secondly, repetition is allowed or not allowed? Well, you see, what is asking you? What is this question asking us? The question is asking us to form a 3-digit number. Well, a 3-digit number with repetition, it is a 3-digit number, right? For example, 222, isn't it also a 3-digit number? Yes.
Yes, sir.
Yes. It is not asking us to form a 3-digit number without repetition. It is just asking us to form a 3-digit number. That means here repetition is allowed, right? Here repetition is allowed, obviously. Okay. Now here the question arises, fundamental question. The task of forming a 3-digit number, it will happen in 3 different events, one after another. After all 3 events have happened, only the task will be complete. But the question is, can we start filling any place, or should we fill some particular place first? Okay, the question is, well, you see here in this question, okay, in this question actually repetition is allowed. It is giving us repetition is allowed. So it is a very easy question. When I ask you repetition is not allowed, there you will get the gist more. Okay, let's see. See, there is a restriction here on the hundreds place. Why? Because if you want to form a 3-digit number, can you place 0 in the 100 place?
No, sir.
Because
No, sir.
Because if you put 0 there, what will happen? You will end up with a 2-digit number, right? But you
Yes,
want to
sir.
form a 3-digit number. So that means there is a restriction here in this place. So wherever there is a restriction, fill that place first. So here in this place you can put either 1, 2, 3, 4, 5, 6,
There are
7, 8,
9 different ways.
9 different ways, right? 9 different ways. 9 ways. Now once you have filled the 100 place, now you can fill 10th place or 1st place, whichever you want. Suppose I want to fill the 10th place. Well, I can fill any of the 10 digits here, right? Any of the 10 ways, right? Because
So 10 ways to
Here
fill
also.
10th place and 10 ways to fill 1's place.
yes, because repetition is allowed, right? Right?
Yes, sir.
So in how many different ways can I do it? 900.
900 different
Sir,
ways.
900 different ways.
And obviously there are 900 3-digit numbers, right? right or not? Yes.
Yes, sir.
Okay. Now you see, in this particular question, actually make a habit of always filling the place with restriction first, because this question is so easy. Even if you fill this place first by in 10 ways, then in 10 ways, and this place you can fill in 9 ways directly. Here this question is very easy. Here you could have started with ones place also. You could have started with ones place. You can fill it in 10 ways. You can fill it in 10 ways, but you can fill it in 9 ways, because here it is repetition is allowed, so no problem. Here no problem. But always form a habit of filling the place with restriction. Always form a habit. Okay, because the second question which I am about to ask you, there it will matter. There it will matter. You get it? Why it didn't matter here? You get it? Because you could have done it. You could have started with ones place, then tens place, then 100 place. No problem. You would have gotten the same answer. You get it? Hello.
Yes, sir.
Sir.
Okay. Okay.
Yes, sir.
Okay. But now the question I am going to ask here, you will have to fill the hundreds place first, no matter what. And the question is, how many 3-digit numbers are there? If repetition is not allowed. See, in this particular question,
Sir, 720.
720 directly you calculated directly.
नो सर, मैंने पहले टेंस क्या कहते हैं वंस प्लेस पे 10 नंबर्स रखे.
नहीं, वही तो मैं बोलना चाह रहा हूँ, वही तो बोलना चाह रहा हूँ. वही तो बोल. सुनो. In this question, guys, do you understand? In this question, there was restriction on the hundreds place, right? Clear? Because you couldn't put 0 here, right? Hello?
Yes, sir.
Yes, sir.
But I told you, here repetition is allowed, so you could have started from here also. I can fill it in 10 ways, no problem. Then I can fill it in 10 ways, no problem. But I cannot fill it with 0, so I can fill it in 9 ways, and very easily you can calculate 900. But in this particular question, you will have to start with the hundreds place when repetition is not allowed. That is why I told you, always form the habit of filling the place with restriction. So let's see how. So the 3 events we have to do one after another, and of course there is a restriction in the hundreds place here, because you will digit all 1 0 1 2 3 4 5 6 7 8 9, no problem, whichever you want to use. But the thing is, in the hundreds place you cannot put 0, right? Otherwise you end up with 2-digit number. That means there is a restriction on the hundreds place. That is why here you will fill the hundreds place first, compulsorily. If you fill the ones place first, you will make a mistake. I will show you. You get it? So I will fill the 100 place first. Now 100 place can be filled in how many ways?
Sir, 9 different ways.
So 9 different ways.
Now this event has already happened, because one event happens, after that another happens, after that another happens. This event has already happened. That means you have put one of those digits here. You have already put whichever you want. For example, you have put 3 here. Now you want to fill the tens place. Well, it says repetition is not allowed. That means you cannot use 3 here again. So you can fill this place by 0 or 1 or 2 or 4 or 5.
So 9 different ways.
Sir, 9 different ways.
So now suppose one of the rest of the digits you have filled here. For example, whichever one, doesn't matter, because there are no problems. You can put 0 anywhere, doesn't matter. Now you are about to fill the ones place. Can you fill one?
So
or
8 different ways.
8 different ways.
So in how many different ways can the event 3 events take
Sir,
place?
648.
648.
Sir, 648.
Now you see for yourself here, if you had started with the ones place, what answer would you get? And you will get the wrong answer. You get it? So always remember, here repetition is not allowed, asking us repetition is not allowed. That means compulsorily we have to fill the place with restriction. in the previous case, the place with restriction didn't have to happen one of didn't have to be filled first. Still, form the habit of filling the place with restriction first. Get my point so far? Okay, that's it. So done. Fundamental principle of multiplication. Almost all important questions I did. Hello, get it everybody? Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Yes, this question. A gentleman has 6 friends to invite. In how many ways can he send invitation cards to them if he has 3 servants to carry the cards? Very interesting question. So the gentleman has 6 friends. How many friends? 6 friends.
The 6 friends.
But he has 3 servants. And the gentleman wants to send an invitation card to each of the friends. Now the question is, in how many ways can he do it? So just think about it. This event, it will happen in this task, it will happen in how many different ways? First of all, what is the task here? The task here is to send an invitation card to each of the 6 friends, right? That is the task, right? And it will happen in 6 different ways. 6 different events. It will happen in 6 different events. Event number 1, you will send an invitation card to friend 1. Event number 2, you will send a card to friend 2. Then you will send a card to friend 3, then friend 4, then friend 5, then friend 6. Then your task is complete, right? That is your task, right? To send an invitation card to each of the friends. Now event 1, which is to send an invitation card to first friend, can be done in 3 different ways, because you have 3 servants. Whichever servant you can send. Okay, get it? In 3 ways.
Yes, sir.
Event number 2, it can also happen in 3 different ways.
3 different ways.
because it is not saying that if you have sent this servant to this friend, then you can't use the same servant to send an invitation card to the other friends. No, it's not asking us anything like that, right? So friend 2 can be sent an invitation card in 3 different ways. Friend 3 also 3 different ways. You get it? So in how
Yes,
many
sir.
different ways can the entire task be completed? 3 into 3 into 6 times, right? Hello.
Yes, sir.
Yes,
To the
sir.
power
Yes,
6
sir.
different ways. Okay. So you got it.
Yes,
Now,
sir.
okay. Now this question. How many numbers are there between 100 and 1000 which have exactly one of their digits as 7? Let me just write the question here. The question is, how many numbers are there between 100 and 1000 if which have exactly one of the digits 7, which have exactly one of their digits 7. First of all, here you have to understand the task, then only you can do the question, solve the question. What is the task here? Entire task. How many numbers are there?
So we have to create a 3-digit number with which can have a 7 at 100 place, 10th place, or 1st place.
Very good, excellent. You see here, we have to find form. I mean, it is asking us how many numbers are there between 100 and 1000. Well, we know that between 100 and 1000 all the numbers are 3-digit numbers, right? 3-digit numbers, right? One and one. So basically it is asking us how many 3-digit numbers you can form, but there is a condition. What is the condition? That those numbers should have or must have exactly one of their digits as 7. Exactly one digit should be 7. Whatever number you form, 7 should be exactly one of their digits. For example, this, right? This kind of numbers are accepted, right? Because in these numbers 7 is used exactly once, right? Hello, get it? Have
Yes,
exactly
sir.
one of the digits.
Yes, sir.
If 7 is used more than once, no, those numbers are not accepted. If 7 is not used at all, then also no, those numbers will not be accepted. 7 has to be used exactly once. So now, in how many different ways can you do this task, or in how many different ways can you fill 3 places, ones place, tens place and hundreds place, so that exactly one of their digits is 7? Well, you see, you will create what, 3-digit numbers, but here 3 different types of numbers you will form. 3 different types. Type 1, your number will have 7 at unit place. 7 at unit place only, right? Because you want to form a 3-digit number with the 7 being used exactly once, so you can form one type of number where 7 is used in the unit place only, nowhere else. Okay, in the unit place only. So now the question is, how many such numbers can we form? Okay, you see that. Hello, get it? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now let's see in how many different ways can we fill the 3 places. Well, first of all, 7 is filled, the ones place is filled with 7 compulsorily, 7 at unit place. So this ones place can be filled in only one way, isn't it? Because you have to put 7 there, nothing else, right?
Yes,
Okay, okay. Now the question is, when you want to fill the tens place, in how many different ways can you do it? Think and answer.
So 10 different ways.
Again, think and answer. Because you have already filled the ones place. That means you have put 7 here. You have put 7 here. Now in how many different ways?
बट क्वेश्चन में ये तो नहीं बोला ना कि हम 7 को रिपीट नहीं कर सकते. उसने बोला किसी भी एक जगह पे होने से चलेगा.
Have exactly one of that is. Exactly one of that is 7. Do you understand the meaning of the word exactly? Exactly one of that is 7. Get it? Hello? Hello, get it?
Yes, sir.
Yes, sir.
Yes, sir.
Exactly one of that is 7. So 7 you have put here. You can't put 7 here or here. So tens place can be filled in 9 different ways, isn't it? Because you, other than 7, any other digit you can use. You get it? Hello, get it?
Yes, sir.
But the
Yes, sir.
but the hundreds place, of course 7 you can't use here. Also 0 you can't use here, right? 0 you can't use here. Other than 0 or 7, any other digit you can use, right? Because if you put 0 here, you will get a what? 2-digit number. You get it? You can't put
Yes, sir.
0 here. You can't put 7 here. But any other digit is fine. So that means in how many different ways can it be done?
Sir, 8 different ways.
8 different ways. One second. Hello. One second, guys. Okay. So, yes. Okay, sorry. So how many different? Okay, guys, did you understand why 8 ways? Hello, 8 ways. You get it?
Yes, sir. Yes, sir.
So in how many different ways can you do it? 8 into 9 into 1, right? 72
So
ways.
72 different ways.
That means 72 3-digit numbers you can form where 7 is used at unit place only. But see, there is another type of number you can form where 7 is used at tens place only, right? Tens place only. Get it?
Yes, sir.
So if you
Yes, sir.
ones place, tens place, hundred place. Now if you fill the tens place with 7. That means you can fill it in only one way. And keep in mind, 7 is to be used exactly once, not more than that. Exactly once, not more than that or not less than that. So now whichever you want to fill first. Suppose I want to fill her ones place part. One place I can fill any number other than 7, right? Any digit other than 7, because 7 I can't use again. Here I have put 7 already. So how many ways can I do it?
So 9 different ways.
9. So now let's fill the 100 place. Well, in the 100th place I can't fill 7. Also I can't fill 0, right? I can't fill 0 here, right? So in how many different ways can I do it? 8
So
different
8
ways.
different ways.
So how many such different numbers we can form? 8 into 1 into 9, 72. But
So
there is,
72.
yes, but there is also another type, type 3, where 7 is used in the
The 100 place.
100th place only. See, now this is a bit interesting. Now we have to fill the 100th place with 7. That means 100 place will be filled in one way, right?
Yes, sir.
Okay. Now the question is, in how many different ways I can fill any one of these first. In how many different ways can I do?
9.
9.
So 9.
different. Because other than 7 I can fill any other digit here. Now I want to fill this. In how many ways can I do it?
So 8 different ways.
5
Right.
different ways. 5 different ways. Why?
9.
Sorry, sir. 9 different.
9 different ways, right? Because you can't use 7, but here you can use 0, right? Here no problem. You
Yes,
can use
sir.
0.
Yes, sir.
No problem. So other than 7 you can. So in how many different ways can you do it?
So
81
81.
different ways.
So total how many such numbers can you form where 7 is there only once or exactly once? 72 plus 81 out of 72. Sorry. 72 plus 72 plus 81. You get it? Hello. 72 plus
Yes, sir.
72 plus 81. Right? Get it?
Yes,
Total.
sir.
So 255.
255.
So
Clear.
225.
225.
225. Okay. Bas. So thank you. Acha, do you have any class here? No. You must be very tired. Some other day we will continue. How about this Sunday? Can we have a class on this Sunday at 4 p.m.? None of you, hardly any of you came to the class. In the last class, hardly any of you came in the last extra class. Why? Only 2 or 3 came. Ayushkant came, and I think somebody else came. I don't remember, Rajesh Pradhan or something. Why else? Why none of you came? Okay. So Sunday we'll have a class or not? Hello. Or in which day we want? What day is today? Today is
सर
Thursday.
संडे को सर 7
Sir,
PM के
Sunday.
बाद कर लेते हैं. उस टाइम से सब कंफर्टेबल होते हैं ऑलमोस्ट.
Okay. See, today is Thursday, right? Tomorrow there is no applied mathematics class, and the day after tomorrow, Saturday, also there is no applied mathematics class, right? So how about we have a class on Saturday in the evening?
Yes sir, it will be okay.
Okay, I will inform.
sir.
I will inform in the group. Everybody always check out the group. Whatever I'm posting in the group, always check it out. Okay. Thank you guys. Bye.
Thank you, sir.
Thank you sir.
Thank you, sir. Thank you, sir.
Yes.